For the intermediate quantitative methods final group project, we will be presenting on teacher attitudes and student testing outcomes. Group members are Amanda Dorston and Erin Wilcox. Using the high school longitudinal study from 2009, we were interested in looking at the effects of teacher attitudes on student standardized testing performance. For the purpose of this project, we have chosen the independent variables as teachers setting high standards for themselves and teachers feel responsible that all students learn. The dependent variable that we have selected is ACT composite score. We will discuss the variables more in depth in a later slide. Because we are using ratio and ordinal variables, a multiple linear regression is able to be used to determine the relationship between the dependent and independent variables. Based on our variables discussed in the previous slide, our research question is there a significant linear relationship between the dependent variable ACT composite score and the independent variables, teachers setting high standards for themselves or teachers feeling responsible that all students learn? The null hypothesis for our research question is there is no significant linear relationship between the dependent variable ACT composite score and the independent variables, teachers setting high standards for themselves or teachers feeling responsible that all students learn. This can be written that the slope for the regression line for both independent variables is equal to 0. The alternate hypothesis for the research question is there is a significant linear relationship between the dependent variable ACT composite score and the independent variables, teachers setting high standards for themselves or teachers feeling responsible that all students learn. We can also state that this as the slope of one or both of the regression lines is not equal to 0 and that there is a positive or negative correlation between the variables. The dependent variable ACT composite score is a discrete variable, meaning it is entered into the SPSS program as an integer. Because we are looking at ACT scores, the score that the student received on the ACT is the number that would be entered into the dataset. However, because some students did not take the ACT, they did not answer this particular survey question, and so on. There are certain entries that are coded as such. For example, you can see that a missing response has been entered into SPSS as -9, and if the question was not administered to the participant, it has been coded as -4. Because these entries would skew the data if left in the dataset to be analyzed, they have been removed from the analysis. Both independent variables are ordinal variables. Each variable is a statement that the participant was asked to choose their response strongly agree, disagree, or strongly disagree. Because these responses have a particular order, they are able to be coded and entered into SPSS as 1. Strongly agree, 2. Agree, and 3. Disagree, or strongly disagree. Like the dependent variable, there are some entries that are either missing, not reported, or left blank. These entries have been coded as -9, -8, and -7, and have been entered into the missing column in SPSS to remove them from analysis.
Now we're going to look at the descriptive statistics. If you look at the data, there are 6,850 participants. The mean for the ACT composite score was found to be 21.93 with a standard deviation of 2.701. The mean for the independent variable teachers at this school set high standards for themselves is 1.77 with a standard deviation of 0.563. And the mean for the other independent variable, teachers at the school feel responsible that all students learn, is 1.81 with a standard deviation of 0.548. The Pearson correlation indicates a negative association between the following variables. For the variable average ACT composite score and the variable teachers setting high expectations for themselves, the correlation was negative 0.165. For the variable average ACT composite score and the variable teachers feeling responsible that all students learn, the correlation was negative 0.177. A positive association is indicated by the 0.636 result of the correlation between the variable teachers setting high expectations for themselves and the other variable teachers feeling responsible that all students learn. The negative associations tell us when the value of one variable increases, the value of the other variable decreases. A positive association tells us that as the value of one variable increases, so does the value of the other variable. Both negative associations have a small strength of association in the case of our variables. However, the positive association in our example, the correlation between variable teachers feel responsible that all students learn, and the variable teachers set high expectations for themselves, there is a large strength of association. Basically, that means all of the points, if they were put into a diagram, would be closer to the same line. For the lesser strength, the points are farther away from the line. Here you'll see the data tables that we received from the SPSS data output. First, we're going to look at the ANOVA table. Looking at the F statistics, 96.999, we know that the data is significant because this value is so high and the p-value, 0.000, is less than 0.05, which was our alpha value. Now looking at the regression analysis table, we can see that the variable teacher standards had a statistically significant negative effect on ACT composite score. We know this data is significant because the p-value is less than 0.05, and we know that the effect is negative because the t-score is negative 9.914. Additionally, we can see that there is no significant effect from teacher responsibility on ACT composite score because its p-value is much higher than 0.05. Also, the t-score is quite low. When both independent variables are taken together, however, they have a statistically significant effect on ACT composite score. Finally, if you look at the model summary table, you will see that the R-square value highlighted is 0.028. This means that when considering both teacher standards and teacher responsibility together, they explain 2.8% of the variance of the ACT scores. While this number is statistically significant, it does not play a very large role in student ACT composite score. When considering the effects of teacher standards and teacher responsibility on learning together, we find that they have a regression equation listed on the screen. Referring back to the R-squared value, this equation accounts for 2.8% of the variance in ACT composite score. Overall, teachers' standards that they set for themselves had a statistically significant negative effect on ACT composite score, with its slope being negative 0.735. On the other hand, teachers' responsibility for student learning was not statistically significant on its own, but when paired with teacher standards, it becomes statistically significant with its slope being negative 0.094. What this means is if we hold teacher standards constant, with 1 unit increase in teacher responsibility, a 0.094 unit decrease is predicted in ACT composite score. While holding teacher responsibility constant, with 1 unit increase in teacher standards, a 0.735 unit decrease is predicted in ACT composite score. We thank you for taking the time to view our presentation. We look forward to your feedback and wish you all the best.